here's going to be some practice on balancing more equations. Make sure that you have the handout that says 5.2 and counting. The next one's going to be 5.2 where you can do mental or counting, and we'll do that one next. So please make sure that you're on this sheet right here. So we're going to be using the counting method, and so we're going to go through all the steps to balance these equations. Now, what I'd like you to do is try to use the steps that we've learned from lecture right now, and I want you to go through and do as many of these as you can. This is one that was actually done in lecture, but we're going to do it a little bit in the reverse, just to get some extra practice and showing that you don't have to do it a very specific way. You can also go about starting with a different element. But I want you to take a few minutes now and go through and do as many of these as you can. Remember, I'm going to go ahead and do number one together just to give you a reminder of how to do this, and then I want you to do the rest of them by yourself. So we first have to list the elements. So we have nitrogen over here, and we also have hydrogen. On the other side, we have nitrogen and hydrogen. We're not going to lose any atoms in this chemical reaction. Then we have to list the number that we have by the subscripts. So we have 2 nitrogens and we have 2 hydrogens. How many nitrogens do we have on the other side? We have 1. How many hydrogens do we have? We have 3. So what we did last time is in lecture, we started off with the nitrogens, but let's start with the hydrogens. So let's say what's going to be the reconciling multiple between 2 and 3? You should be saying 6. So I'm going to have to multiply the H by a 3, and that's going to be the coefficient up here. So this is going to go right up there, and that's going to be 3. Now it's not multiplied by the n because that's by itself. We're only multiplying the H, so we have 3 times 2, that's going to give us 6 hydrogens. Now over on the other side, what's going to get us to 6 is multiplying the hydrogens, the 3 by 2. That will give me 6 as well. So this 2 is going to be coming up here as the coefficient. We're multiplying it by 2. We're multiplying the 2 by 3 to give us 6, but look at, we're also multiplying the n by 2. So we have to multiply the n by 2 as well, and that will give us a 2. And if you look at this, we now have 2 nitrogens and we have 6 hydrogens. That is balanced. So please go through and do as many of these as you can, and then come back for the 1, 2, 3, 4, 5 more problems. Okay, this is going to be the solutions for all these. And again, we're going to do the same steps that we did previously. We're going to start by listing the elements. We have Na, Cl, and F. On the other side, we have Na, Cl, and F. The next step is we have to list the number of elements that we have, or number of atoms that we have by their subscripts. We have 1 Na, we have 1 Cl, and we have 2 Fs. Over here we have 1 Na, we have 2 Cls, and we have 1 F. So it appears right now that my sodiums are balanced. Going on to my chlorine is not balanced. So I'm going to multiply the chlorine by 2. So I'm going to put this up here. So I'm going to draw the arrow there. So now we have 2 chlorines, but that means we also have 2 times 1 of the sodiums as well. So that's going to give us 2, and that's going to give us 2. We have 2 sodiums, we have 2 chlorines. So now the chlorine seems to be balanced. Well, now we have a choice. We can say, oh, I'm not balanced here, or I can just continue going down as well. Let's just continue going down, and we'll come back to that if necessary. So with fluorine, I have 2 here, I have 1 here, so the least common multiple is going to be 2. So I'm going to multiply this side by 2. So what has the fluorine? This has the fluorine. Multiply this by 2. So it's 2 times F, but it's also going to be 2 times Na. So we could have either done the Na first, which would have given us the 2 Fs, or we can do the F and multiply that by 2, which would give us multiplying the Na by 2 as well. And if you notice, it's going to be 2, 2, and 2, and it's all balanced. Going on to the next one, we have 3 elements. We have carbon, hydrogen, and oxygen. Same thing on the other side, carbon, hydrogen, and oxygen. Just as a reminder, these ones are going to be tricky, these combustion reactions that require oxygen, because take a look over here, we have oxygen that are found in 2 of the chemical formulas. So we'll get to that troublesome part in a few minutes. So let's take a look and count the number of carbons. We have 1 carbon here. How many hydrogens do we have? 4. How many oxygens do we have? We have 2. 1, 4, and 2. How many carbons do we have on the right-hand side? 1. Hydrogens? 2. Oxygens? Tricky. How many do I have here, and how many do I have here? I have 2 here, 1 here, so therefore I have 3. So let's go through one by one. My carbons seem balanced, so I'm not going to touch those now. These are not balanced. What's the least common multiple between 2 and 4? It's going to be 4. So I need to multiply this by 2. So I'm going to multiply this by 2 here, and this is going to give me my 4. So it's 2 times 2 gives me my 4, and then 2 times 1 gives me 2. But remember, I also have oxygens over here. So what's the total number of oxygens that I now have? Notice how I'm not multiplying this by 2, because I'm not doubling the 3 that I have. I'm only doubling the 1 that I have. 2 times 1 is 2, plus 1 times 2 is 2. I now have 4 oxygens. What's the common multiple between 2 and 4? It is going to be 4, so I'm going to multiply the oxygen by 2. 2 times 2 gives me 4. Is it multiplied by 2 by anything else? No, oxygen's all by itself over there. So that is the balanced equation for that. Next one is looking at phosphorus, P, oxygen, O. On the other side, phosphorus and oxygen. List the number of P's that we have. 1. Oxygen, 2. P's over here, 2. Oxygens, 5. This one's going to be a little bit tricky because we're going to have to go back, and sometimes you have to go back and change things. So what's going to reconcile 1 and 2? I'm going to have to put a 2 here. 1 times 2 will give me 2. Now the phosphorus is our balance, so I'm going to put a 2 right there. Now going on to this next one, what's going to be the reconciling factor of 2 and 5? The multiple is going to be 10. So I'm going to have to multiply my oxygens by 5. 5 times 2 gives me 10. How do I get 10 from 5? I have to multiply by 2. And that's going to be the coefficient up here, 2. So that 2 goes over there. 5 times 2 equals 10. So now my oxygens are balanced, but if you take a look at this, I had 2 times 2 for the phosphorus and 2 times the 5. 2 times the 5 gave me the 10, but 2 times 2 now gives me 4 phosphoruses. Well, now I have 2 phosphoruses over here, so I have to multiply that by 2. 2 times 2 would give me 4. So since this one was tricky, let's go ahead and check. We have 4 phosphoruses. Here we have 2 times 2, or 4 phosphoruses. Here we have 5 times 2, which is 10 oxygens. Here we have 2 times 5, which is 10. That one is balanced. So that one was a little bit tricky as well. On to the next. We're going to list our 2 elements. We have sulfur and oxygen. On the right, sulfur and oxygen. Here we're starting off with 8 sulfurs and 2 oxygens. Here we're ending up with 1 sulfur and 3 oxygens. Let's just start with this one. The common multiple between 1 and 8 is going to be 8. So this is the coefficient that goes up here. Now I have 8 sulfurs, but I also have 8 times 3, which is going to give me 24 oxygens. My sulfurs are balanced at 8, but now my oxygens are not balanced. What's the common multiple between 2 and 24? It's 24. So how do I get to 24 from 2? Multiply by 12. And then we're balanced. Last one, list them. Sodium, bromine, calcium, and fluorine. Sodium, bromine, calcium, and fluorine. Okay, list by the subscripts. I have 1 Na here. Equals 1. Bromine is equal to 1. Calcium equals 1. Fluorine equals 2. 1, 1, 1, 2. On the right, I have 1 sodium, 2 bromines, 1 calcium, and 1 fluorine. My sodiums appear to be balanced for now. These are not balanced, so I have to multiply this by a 2. So find the bromine, thing that has bromine. This has bromine, so we're going to put the 2 there. That gives me my 2 bromines, but it also gives me 2 sodiums, so I have to multiply the sodiums by 2 as well. So we get 2 and 2. Calcium is balanced for now. The fluorine's not balanced. You have to multiply the thing with fluorine by 2 to give me 2. So multiply the 2 right there. That's 2 fluorines, but also 2 sodiums. So I have to go back to the sodium and multiply that by 2 to equal 2. Appears we're balanced with 2, 2, 1, and 2. Let's double check. I have 2 sodiums, 2 sodiums, 2 bromines, 2 bromines, 1 calcium, 1 calcium, and 2 fluorines and 2 fluorines. We're balanced.